Question number 5. The inside of a funnel of height 10 inches has circular cross sections, as shown in the figure above. At height h, the radius of the funnel is given by r equals 1 over 20 times 3 plus h squared, where h is greater than or equal to 0, but less than or equal to 10. The units of r and h are inches. So for part A, you have to find the average value of the radius of the funnel. So to find the average value of the radius, you will have to use an integral. So our integral would be from 0 to 10, and our equation will have to be the radius of the funnel squared dh. And so once you have your equation, then you proceed, since this is an integral, you will proceed to take the antiderivative of that integral. So the antiderivative of this equation would be 3h plus 1/3 h cubed from 0 to 10. If you're wondering how we got 1 over 200, so we took 10 minus 0, which is 1 over 10, and so we took the 1 over 20 and multiplied that by 1/10, and that's how we got the 1 over 200. And so once you figure the antiderivative of the integral, you could just plug in for 10, multiply by 1 over 200, and your answer will be 109 over 60 inches. The reason why it would be 60 inches is because the units of r and h are inches, so therefore your units will be inches for the average value of the radius of the funnel. So part B says that we have to find the value of the funnel. But before we find the value of the funnel, we must take the area. Well, we must find the area of the radius. So we will plug in our equation for r, and we will square it. And whatever that is inside will be squared. So then we will have pi over 400 times 9 plus 6h squared plus h to the 4th. And so when we're finding our volume, we also have to use the integral, and we'll also be using the area to find our volume. So it'll be 9 plus 6h squared plus h over 4, dh. And so our volume will equal pi over 400 times, before we multiply, we must find the antiderivative of this equation as well. So the antiderivative would be 9h plus 2h cubed plus 1/5 times h to the 5th from 0 to 10. And so the volume would be pi over 400 times 90 plus 2,000 plus 20,000 inches cubed. And this is all for when you plug in 10. And the reason why our unit is cubed is because we are finding volume. So part C is saying that we have to find the rate of change of the height of the liquid with respect to time. So we could think of this part as incorporating related rates into area and volume. So we could set up our little table. Got a little table of values and units. So the problem already gives us h, and h equals 3 inches. And they've also given us dt, which is the rate of change of the radius which would be negative 1/5 inches per second. Now, in order to not get yourself confused, it will be negative 1/5 since the radius of the surface of the liquid is decreasing. So that's when you know that is negative. So using chain, we are going to use chain rule for this equation. So this equation, you use chain rule in order to solve for dH and dt. So our equation will look like this. And you are going to solve for dH dt. So we could plug in our values. And we will end up getting something like this. Now, before we get to our final answer, we can just multiply everything. We can just multiply everything by 10. So therefore, we will get 3 times dH dt. So you get dH dt by itself, and we will end up with negative 2/3 inches per second, which is the rate of change of the height of the liquid.